Okay, we're probably good to go ahead and get started. I did try and take a stab at this problem beforehand with a draft. Yeah, I did kind of walk through it. The original problem scope usually doesn't entail having text search. Usually is just the upload and the view part. Kind of looks like either of these, depending on whether or not you're going to treat the bandwidth bound aspect. I actually only saw for resources, I only saw grokking. I checked all four of my books. Yeah, only grokking had coverage of this out of all four of my books. So it's really not that exciting of a problem. It's about as easy as tinyURL. I was going to say it might be easier, but the object store part is actually a little bit more not exactly something you see every day. All right, I'm going to pretend like you guys know what Pastebin is. So it's a website where you can upload text, and then you can view the uploaded text. It's a great tool for sharing a really big text blob. And so we're going to handle both of those. And then I noticed that Pastebin actually does support a text search functionality. It's not normally covered in the problem scope, but I'm going to go ahead and cover it. And that is actually what made this question really interesting. I actually wanted to cover this in a 6-minute video, and covering these two was pretty easy. And then I started trying to add in this extra feature that most people don't handle. And then I quickly realized that, oh, this is actually kind of tricky to do in an optimal way. There's like a couple of approaches to try and make this work properly. And so that's why I was like, okay, maybe this would make for better material to try on a live session first before I try and do it in a 6-minute video or something, because I might screw it up. I mean, I've definitely got at least one, total solid working. My voice is not audible in YouTube. Well, I was on mute for a while. That might be what you're talking about. Okay. Anyways, yeah, I have at least one solid working approach for the text search, but it was like there's a couple of different options, and it's not clear what's like the most optimal, solid, great way to do this. If you were to scale it way the hell up beyond what the normal prompt is, and that's what makes I'm going to do that because that keeps the problem exciting. Out of scope is going to be a hit counter. That is a thing that it supports, and a user account system. I usually throw this out. It's just totally, I don't think user account systems are exciting at all. So numbers, we're going to support 1 million pastes per day, which comes out to a write of 10 reads per second. And we're going to have a 5-to-1 read-write ratio, which is a 50 reads per second thing. We're going to support up to 10 megabytes. Which is bigger than what I believe a normal packet size is, which is fine. That's why I'm using I'm going to use an object store here. And we're going to say an average of 10 kilobytes per second, which means that it'll come out to 0.5 megabytes per second on average. I'm going to tweak that at some point, so that way we can actually say that we're bandwidth bound and this will be an issue. But those are the normal things, and you only need one machine per service for that. So let's go ahead and tackle the normal scope. First, we'll start with just the normal scope, and then I'll start exploring the options for supporting text search that I found to be the much more interesting aspect of this problem. Any questions before we jump into the diagram and tackle the first scope for this problem? Cool. All right. Yep. I'll go ahead and jump into it then. So we want to allow uploading text and viewing the uploaded text. So we are going to have, we're going to need 2 backend services. We're going to need 2 browsers. I like to start with my entry points and exit points. It's the easiest part is like you just have your requirements, you just translate them directly into boxes for the browser. So we're going to have the text uploader. We're going to have the text downloader. And then, so we got the upload service, we got the download service. happy text download service. I'm gonna show the naive approach first. You don't normally see a naive approach in the books, even though for coding books like Gale's Cracking the Coding Interview, or in EPI, I think it's or even on LeetCode, you'll usually see like the non-optimal approaches. And I was like, why? We don't really have those in system design, and everyone will show their best approach, but even more interesting sometimes, what can provide a little bit more insight sometimes is what an incorrect approach or what some common mistakes are. And so I'm actually going to do a naive approach that'll be bandwidth bound first. At our current scale, it's totally fine to be, you can probably get away with this bandwidth bound approach, but if you crank up the scale by like 10,000x, then you'll see it's bandwidth bound. And so then that would affect how you can optimize it for machine counts. I'll maybe do those numbers for cranking up to 10,000x after finishing the first original scopes. That'll kind of illustrate the difference between the bandwidth bound and the non-bandwidth bound approach. With that, let's go ahead and get the object store on there. That is like the most obvious thing that you're going to need, is that you're going to have this like text object store. So while doing some research on this problem, I found that Elasticsearch does actually support records of up to 200 megabytes. That was like really shocking, that like you can actually store so much data in a single record in Elasticsearch. So you can actually kind of get away with that, but it just doesn't seem like the most optimal thing for that. You'll see it come up again when we do the text search thing, is that one of my approaches is actually going to go ahead and use Elasticsearch as we're not even going to have an object store in one of the approaches. And that'll be fun. And then, so let's talk about this first. So in a naive approach where you have that bandwidth bound aspect, you can just go ahead and have the text go straight through the upload service. And so then that's turning this into a bandwidth bound thing. With an object store, you can actually upload directly to an S3 bucket with a pre-signed URL. So you're going to get something that looks kind of like this. And then you should probably have a metadata store. So this one will be S3. Wow, it didn't capitalize that. Weird typo. And then depending on the scale, you can either do PostgreSQL. That works fine for the scale that we have currently. Or if you need to scale it up, DynamoDB for eventual consistency. But at the current scale, PostgreSQL would work fine. And in fact, it's like you might even be able to get away with Elasticsearch and just combine these completely. Yeah, let's keep going though. Yeah, so this is a naive approach because it turns this into, it could become bandwidth bound through here. Normally when we have really large assets, we actually want those to be downloaded straight from a CDN or wherever your media is stored, straight to the downloader. So let's go ahead and do that next. But first, I'm going to label this the naive approach. I see a question in the chat. I'll get to that in a second here. That's labeled. Cool. There we go. And now we're going to try to do a more optimal approach. And this one is naive because it is potential for bandwidth bound. Okay, I'm going to address your question now in the chat. By the way, why are we having two text stores? Just to know more. So one of them is actually the metadata store. The other one is the full text store. So this one actually has the full text itself, while this one would be a mapping to the S3 bucket. So in the schema for the, oh, I said object store. I'm really sorry about that. It's not an object store, it's a data store. It's the metadata data store. Yeah, I think yeah, and then I just copy pasted that. So that's going to be ambiguous on the other diagram. I'm sorry about that. But it is the metadata data store. And the schema is going to look like, we're going to have, you could have a, you would need to have the URL route. It's some kind of unique ID. So it'd be the text key, the key for accessing it. And so I actually just did a paste a minute ago. I think I already threw it out, but it was like XGH 842X or something. So you might even need to use a key generator service and have that plugged in here. UUID generation is apparently a problem of its own, and I don't want to focus on it a whole lot. So I'm just going to have that outsourced to a special component called a key generation service. So you're just going to make a request and response to get a key from that. You're going to store it into there's the primary key, and you're also going to have the S3 URL is going to be another important attribute. What is it? They have their own special. I thought S3 might have even had its own special protocol or something for how it's addressed. I'm just going to ignore it. And that's where your object is specifically going to be. You might have some kind of other metadata in there, like the uploader. If you were going to have hit counts, you also maybe store that on the record as well. But yeah, so that's the metadata. You would not have the text inline directly there. Yeah, okay. We can move on. So that presents, that can make it bandwidth bound. If we did like a 10,000x on these numbers, it would you turn this into a bandwidth bound while you can circumvent it by having them do a download directly through there. You would still need to have them you would still need to call the metadata service first. You would need to so to address you'd first need to figure out what the location of the S3 bucket is first. And then the client would be able to pull directly from that S3 bucket. You can actually host entire static sites directly off an S3 bucket. And then also you could even have a bandwidth bound thing here. In the case of Pastebin, that's particularly unrealistic. But when we 10,000x everything, it just turns into a much more fascinating problem that allows us to better test, I feel, system design skills. And so when we have like 10,000x the write throughput, you might actually want to eliminate any kind of potential for a bandwidth bound spot here. And so then you would you can use a pre-assigned URL over there for the upload. And then on the download, it's just you can pass them the location of the S3 bucket directly. So that eliminates a lot of the potential for bottlenecks. And then you can even throw load balancers in front of both of these. But it's, we're getting a little unrealistic with the scale. But sure, let's go ahead and do that. But for the original scope of the problem, you would definitely not need a load balancer at all. You would just need maybe one machine here, maybe two, just to make sure that you have one for failover. So two for that, and then for the S3 buckets, I mean, you normally don't do, I would need to calculate how much, how many hard disks we're going to need, and then probably triple that just for redundancy. And then this one, you should also have redundancy there, but it's probably going to come out to like 3 machines. I'm just spitballing on that. Let's maybe go ahead and have some real numbers for that. So 1 million at 10 KB average. So per day storage requirements, we would have 10 kilobytes, 10 megabytes, 10 gigabytes per day. So we would have. And so per year storage requirement is 365 times 10, so that would be 3,650 gigabytes per year. And so, so that would be 3.65 terabytes per year. And then let's say we're planning 10 years out. So for 10 years, permanent storage, we're supporting permanent storage. That should be in the numbers. You should clarify that up front. So for 10 years permanent storage, you would need 36.5 terabytes. And with 2 replicas for redundancy, you'd need well, okay, so with this, let's say that you can support 100 terabytes off of one hard disk. I think that's realistic. And so then you would need 3 hard disks or like 3 machines over here to support the disk storage for the actual text blobs. And then this one's going to be way smaller. You should maybe have at least 2 machines running that, just to have at least one for a failover, maybe 2 failovers if you want to really make sure it's durable. Yeah. Okay. So that's what we got for original scale. Let's maybe go ahead and write that. That way people will have it in the Excel diagram thing that I'm going to post in the pinned comment. So 2 machines here, 2 machines here, 3 hard disks, and then we would have 2 machines, 2 to 3 machines. Whoops, 2 to 3 machines. 1 to 2. Whoops. 1 to 2 for failover. Normally for services, I think it's good to have just 1 extra for failovers when just like one's going down. I think it's probably a better idea to have 2 extra copies for redundancy when we're talking about data stores. Because when stuff goes down with your data store, there's the potential for data loss. While with these, it's just failover, and like all the worst thing that can happen here, when you have a little bit more machines go down than expected, is that you're just gonna have a little degradation in your availability. Well, over here, if more goes down than expected, you would potentially have data loss, which is a much bigger issue than just having a little bit of downtime. So yeah. Okay, so we have machine count estimates for the original scope. You can even have, well, the load balancers aren't really super necessary for the original scope. Yeah, I want to have them there for, let's go ahead and do, let's go ahead and do 10,000 X scale. So now we're going to have 100,000 reads per second. We're going to have 500,000, whoops, 100,000 writes, and then reads, writes. I'm messing up my words here, sorry. Let's do 500,000 reads per second. See a question in the chat. How do we do user ID to paste ID mapping? So the paste ID, so the text key is the text key is, I believe, what we're talking about with the paste ID. And then, well, so we're not going to have user accounts within scope, but you would be able to have extra metadata over here, such as the user ID. So when they're uploading, you would have the user ID come along with the request to upload some text. I actually could possibly even walk through the full process of how the upload looks like with when you're doing it properly with the pre-signed URL, is that you'd first create the record. So yeah, let's go ahead and copy this thing and I'll paste it over here. So you will, so you've got your user ID for a logged in user. And so then you have your user ID and you've got all this text. So you're first going to want to create a record with a key ID. So then you got your thing that looks kind of like this. You got the S3 bucket. I think you can even have a status. So that way it will maybe allow you to do some nicer cleanup of for when if the browser, like if the client loses their connection during the upload process or immediately following it or something, they don't manage to send the ACT, the upload service. But first they're going to do this, and then you'll maybe have a status. So say pending upload. And then you go ahead and it returns your S3 URL. I believe this is the thing that's going to go ahead and do some kind of request to S3 to get that pre-signed URL. And then it'll go ahead and pass that and the key ID from the key generation service over into the metadata store. I omitted the key generation service. I'm going to put that over here. We got the key generation service. So we're going to say request comes in, upload service grabs the key generation service, gets an S3 URL, sticks them in here, and then they do the multi-part upload over to the S3 bucket. Boom. When they're done, they send an ACK over the upload service. Upload service goes ahead and it updates that status for complete. And now that text should be findable for the browser when it finishes replicating on DynamoDB or anything like that. Yeah. And you can record your user ID in the metadata store too, though. So then if you want to have users that are able to delete their pastes, if you want to support the ability to delete a paste, that would allow you to do it, is that you would just need to have that handled by the auth. Okay, I didn't talk about latency yet. I wanted to handle that. I was in the middle of handling the bigger scale. We'll handle the bigger scale and then we can talk about latency. So 10,000x scale first, and then we'll talk about latency. And I'm going to make a little mark just to make sure that I don't forget. Okay, so we have that, it's 10,000x scale, and we're going to have the bandwidth is 10,000x, which would be 5 megabytes times 1,000. That is 5,000 megabytes or 5 gigabytes of bandwidth per second. And that is gigabytes, not gigabits. Any chances of hot partitions? Okay, so if you, I mean, you could have a user ID that is like particularly is particularly heavy on creating pastes, if it's like a company account or something that's using it for an integration thing. And so then if you so you would maybe want to avoid partitioning by user ID. Let's do consistent hashing over the, you could even do, oh, I mean, yeah, okay, so you're going to use the paste ID or the key as the partitioning key. And then user ID could be a sort key. So paste key, partition key, and then user ID. Make for a nice sort key. You don't actually need it as a sort key. This would be sufficient for being uniquely identifiable. So this would either be a sort key or secondary index. it'd be a lot more accurate to call it a secondary index. I don't know if you really, yeah, it doesn't even really make sense to call it a sort key because it's just not necessary for being able to uniquely identify it. So we'll call it a secondary index. Yeah, let's go ahead and write that over on this thing. Yeah, so we're going to say partition key. And then this one would make for a nice secondary index. Yeah. Cool. Okay. Yeah, 5 gigabytes. So 1 gigabit is actually the most common. Usually people have a 1 gigabit connection, not a gigabyte connection. So that would come out to 40 gigabits of bandwidth per second. And for an EC2 instance, you actually get normally about 10 gigabits of bandwidth. So you would actually need 4 EC2 instances in order to handle 4 EC2 instances for handling that kind of bandwidth. But that is assuming that we would be having the text go over. So this is the amount of bandwidth you would need for the text itself. So if we eliminate so what did I use for this? Was the upload, this was the upload volume, I think, right? I said 0.5 times. No, it was the read TPS. Okay, so that is the read bandwidth. So I did do a 10,000x on the read bandwidth, not the write bandwidth. So the write bandwidth is going to be 1/5 of that, or and then for writes, it's 1/5 of that. But that's of course going to be handleable from 1 EC2 instance then. So it's 1, and then you have 8 gigabits per second. But still, so you can see that this would be a bandwidth issue if you actually did the reads of the text straight over the download service. And now by having it go off of that, you can probably keep it down at 2 machines, just having that +1 for a failover. And so you would still need to have, you know, this is definitely going to have bandwidth issues. But over here, you're going to be just fine. You can handle it with just 2 machines possibly. Well, actually, how many reads are we handling per second? It's 500,000. Well, so that's not going to be bandwidth bound. I mean, it still is going to be bound somehow. I feel like you can't actually handle, I've never seen anything handle more than 1,000 TPS off a single machine. So it's going to be bound by something, maybe connection bound, but it's not going to be bandwidth bound. So, yeah. Okay, I think we got some more questions in the chat. In this case, then, to fetch all text or paste for a user ID, we have to do, yes, so you would have scatter gather in that case. Yeah, you would have to do scatter gather if you're going to search, if you're going to do a key range query of a specific user ID. And yeah, that would be a problem. So I noticed that with Pastebin, the search functionality is actually a premium feature. You have to pay for it. You don't need to have an account in order to upload a paste and view a specific paste. But if you want to try and do a search, you have to have an account. I think you have to pay money for it. And so I think that's how when you do scatter or gather, it's going to hit every partition. That's why that's such a huge issue with what Sarov had brought up, is that user ID as a secondary index is, of course, huge issue there. So if you were to let all the users search, then yes, I think that user ID should maybe be a partitioning key instead. Because then, although you're going to have a hot partition issue, you would not have scatter gather on the search. So another important thing to say, even in that case, you'd also want to look at the balance between the search versus the individual paste lookup. So if even if you do have to do scatter gather, as long as the volume of those search queries is really low, if it's like 1,000 times lower than the individual lookups, you'd probably actually still be able to get away with the scatter gather. But yeah, that's a really key trade-off is if you're going to support queries by user ID. And I was just kind of glossing over that and not really focusing on that as part of the scope for this question. But that is a very great call out. Yeah. Which bandwidth can a single machine handle? 10 gigabits per second. Yeah. Okay. I looked this up, and EC2 supports 10 gigabits per second. It has something it can support bursts of higher than that, but that's bursts, not like nonstop at higher than 10 gigabits per second. And it's bits with a lowercase b, not bytes. So that's why I did that conversion from gigabytes to gigabits, is that it was specifically 10 gigabits per second. Yeah. And I mean, so I've seen stuff come up with a cache. That would make sense if you could do a time to live. So one approach you could do is a time to live. If most of the reads happen within like a day or two after you do an upload, then if you just set the time to live of like no more than a week, maybe just stick with 1 or 2 days, then it would totally make a lot of sense to use a cache there. But if it just remains evenly distributed, it's if there's not like that 1 to 2 day time to live thing, that makes sense, and it's just always constant and distributed, you would actually end up having to do a money trade-off of whether or not it makes sense to do a cache. But usually you're going to see most of the traffic like immediately after the upload. And so that actually would be very interesting. So you would maybe want to do, you could do a push-based CDN, and then that's going to be a little complicated to draw. I really want to do this text search stuff that I was really focused on. But caching though, yeah, I totally think that's a really interesting extra way to deviate that. Maybe I'll come back to the caching part after doing search. So we're going to do so I want to do 1 latency, 2 search, and then we can do 3 caching with the TTL of the text. Yeah, latency estimates. So this is something that is for, I heard if you do a staff level interview with Google, they actually want to see end-to-end latency estimates. So this is something that I haven't done in any of my other videos, but I really wanted to have it, at least something. So let's maybe go ahead and do that with this thing right here. Is we're going to go through latency estimates. Yeah, let's just go ahead and stick that right here and scoot it over a little more. Okay, and then we're going to say latency estimates. Let's make it extra large. Okay, so an around the world packet time is about 150 milliseconds, but this is off of a client browser. So whenever it's somebody that's on their browser, they could be on North Dakota, they could be out in North Dakota with a dial-up connection or something. And so I feel like you might want to set this time right here to 5 seconds right there. And then right around here, it's going to be pretty quick. Within data center, times are around, what was it? Data center round trips are about 0.5 milliseconds. So that one is not going to be your bound at all. We can just go ahead and use that here and here. And well, so this one's also going to have to do a write to disk, and shoot. what was the time for a write to disk? Seek, read. I'm looking at Jeff Dean's numbers over here. I don't think it had anything. Yeah, I don't think it had anything talking about a write operation. It just had a seek. Well, so we're gonna have to do at least a seek if we're gonna do a write, which is 10 milliseconds. Oh wow, that means that you're gonna have to. Yeah, I keep forgetting that like disk times are like way slower. And then what is it for like a read? Reading 1 megabyte off disk is like 30 milliseconds. We can go ahead and say that this whole thing is maybe going to take 50 milliseconds total. So for latency estimates, there's like the P50 and then there's like the P90. You got like P50 and then you have like P99 times. And I'm just going to focus on the P99 times. That's what I'm kind of doing over here. Because I talked about North Dakota over here. I've just from working at Amazon, when I was at Amazon, we were way more focused on the P99 and we didn't really think very much about the P50. So I'm kind of doing estimates for the P99 over here. In fact, over here, let's maybe go ahead and say it's 5 milliseconds, and I'm going to say 50 milliseconds total. We'll say, I'm going to say like 10 milliseconds over here. I'm going to say 10 milliseconds over here. So all these calls within the data center, let's just go ahead. Like we've got 3 different things we're going to have to do sequentially over here. And I'm just going to say that they're all going to come out to like 100 milliseconds. Okay, so we have that, and then it's going to do a return, and then this guy's going to have to do their upload. So we're going to have one first call to upload service, the whole thing. It's 5. Well, so it's 5 milliseconds round trip, I think, over here. 5 milliseconds round trip. So it's like 5 seconds. Whoops. Here it is. Okay, 5 seconds plus 100 milliseconds for all the stuff within the data center. And over here, you're going to have another 5-second thing for that. And you can have up to 10 milliseconds being uploaded. 10 megabytes being uploaded. And the average is how many kilobytes? 10 kilobytes average, up to 10 megabytes. So I'm going to talk about the 10 megabyte scenario for the actual write operation. And it was how much for 1 megabyte. Why does it not have writing on here? This is, so you have to do a seek, so that's 10 milliseconds. And then 1 megabyte from disk versus from memory. Okay, 30 milliseconds per megabyte is what we'll say for the write. And we have 10 megabytes max. That would be 300 milliseconds plus the seek. So we have 10 milliseconds seek, and then we have 300 milliseconds of writing. So I mean, it's like half a second there, plus the round trip. So we will say 5.5 seconds for the S3 part. And then again, you're going to have to call this thing right here, which is another round trip. So that's 5 seconds for the ACK to the upload service. That's 15 seconds in total. Quite a bit. That is quite a bit. But it's for the P99. So Okay, then we can talk about the download part. So we're gonna have another 5. We're gonna assume it's another guy in North Dakota with a dial-up connection. Let me move this back down. Maybe I said something controversial. I got a lot of comments on the video. We'll see. Yes, okay. Can you say how you arrived at 5 seconds at the start? I assumed the client is using a dial-up connection in North Dakota. And that's just a rough estimate, my roughest estimate. This is from my own experience working on I worked on a web front end when I was at Amazon. It was not for Amazon.com itself facing the buyers. It was actually for the part that faces the sellers. And my own experience was that the P99 for our browser users, like within the data center, when we're talking to other services, you'd get like a few hundred milliseconds just fine. It was easily within a few hundred milliseconds at the P99. But whenever we were talking about browsers, you were talking about a few seconds, and our timeouts would be set at like 30 seconds. Those were really high, but I'm fairly certain our P99 was not actually our P99 might have been above 5 seconds, but we were also doing like a ton of stuff. We were doing something way more complex than what we're trying to do right here with Pastebin. So I think 5 seconds for Pastebin for a round trip is going to be pretty fine. It's a much smaller packet. We also were sending a lot of, we had a lot of stuff that came down with our calls to the users. See another thing. Any restrictions on the total size of the text being uploaded? Yes, 10 megabytes. With an average of, what was our average? Oh, 10 megabytes max upload, 10 kilobyte average. Yes. Cool. All right, let's go back to here. So again, we're going to have a 5 millisecond within data center time over here. It's first going to do the lookup over there. And again, I'm assuming this is a guy with dial-up in North Dakota. And then we're going to have this part over here, just again, 5 seconds round trip. And then you also have 10 milliseconds seek, and then it's 300 milliseconds of reading. This one's going to come out closer to, so we've got maybe 310 milliseconds here on the actual machine. That would come out to 5.5 seconds at most. Where was I writing these down? So I wasn't saying, it wasn't, okay, it's 5 seconds, and then it was 3, be closer to 15.5 seconds, but really, you know, that's not that far off from 15 seconds. At 300 milliseconds there, 100 milliseconds for everything within data centers, that's 100 milliseconds. Then it was like 310 there. So sum these together, 500 milliseconds. Over here though, 500. Okay, let's do, yeah, step 1 is the download service for figuring out where we want the thing that's where we want the where the S3 location is of the text that we want. And so we have 5 seconds plus a 5 millisecond thing there, 50 milliseconds of reading plus that's 65. So again, up to 100 milliseconds, and then that, but we don't have the third call for ACK. So it's going to be maybe 10.5 seconds for the download side at the P99. There, end-to-end estimates. Cool. Question in the chat. Key generation service pre-generates auto-incremented keys or random keys. I was just trying to outsource all of the logic for figuring out how to do the unique identifiers for it. Because that's like a question all of its own is an interview question all of its own is like create a unique ID generator. So it just pre-generates some keys for us, and we don't have to wait for it to do any generation before it returns. And Brocking actually had this nice call out that like, hey, what if your machine fails, is that you would just have a second one as a backup. I think there's a thing you can do where you can also use Zookeeper to help you, like with Twitter Snowflake. It actually does something with Zookeeper to help it generate some keys so that to like make sure that the two different machines don't conflict with each other. Yeah, but anyways, that's like a whole thing of its own that I didn't want to focus on in this question, but they're going to be pre-generated so that I don't have to worry as much about the times there. Let's go ahead and talk about search a little bit. Yeah, okay, let's talk about the search. There we go. Okay, I had a few different approaches for this. Kind of looking at my notes to make sure that I don't miss anything. So we can do there was the Elasticsearch approach. Yeah, okay. We're gonna have a searcher. And we're gonna have the combo data store, accurately named for just storing everything in the one spot. It's just going to use Elasticsearch, which actually supports up to 200 megabytes per record. I was really surprised when I found that. I was very shocked when I found out that Elasticsearch actually supports up to 200 megabytes each. So this is the search service, and Elasticsearch has a inverted index. That's why I picked it. And we have it like that. And then the issue here is, of course, that, well, for starters, that we would make this bandwidth bound. So this would be a naive bandwidth restricted approach. So we might want to try and get rid of this bandwidth bound thing on the download service. You would, of course, still need to use Elasticsearch on the search service. But what if we could use the S3 bucket? And so this approach is actually going to be an invalid approach. In the process of trying to come up with this one, I actually discovered Elasticsearch doesn't have it does not have DB triggers. I was hoping to use a DB trigger, and then you would just be able to have a object data store, and it would just be S3, and then you'd be able to do this nice little thing where you just copy it over here, and then the downloader would they would first need to figure out where it is, and then they would want to download the text itself. So would still do a read of the metadata, but you would not be trying to pull the full text data down to that. And then when you know where it's located, you would pull the full text blob off of S3. And then this would rely on a DB trigger, but those are not in Elasticsearch, to my great surprise. So we're going to call this the invalid approach. And I think one of the most dick moves that an interviewer could do is challenge you on whether or not Elasticsearch is big enough for that, or there's a couple of nuances of Elasticsearch that I've brought up in this that have made this is the whole reason why the search approach, the search functionality is so fascinating for this problem, is that all the stuff you intuitively want to do, such as a DB trigger or shoving, or like I was so surprised that you could actually fit 200 megabytes in a single record in Elasticsearch. And I was like, there's so many fascinating things about this. Okay, I see some comments in the chat. See, what about Postgres? And yes, both Postgres will push via change data capture to Elasticsearch. Yeah, okay, so there's that. That's one of the things I was thinking about, is putting something out front of Elasticsearch. Or yeah, we can, but then it starts to look really complex. And it's one of the other approaches I was thinking about was like, what if Elasticsearch can't support the size of thing that we want, since like a packet has a 65 kilobyte limit, and then so maybe you could like roll your own inverted index, kind of like Google does for their own search engine. You don't use Elasticsearch for google.com. And then it looks a little bit similarly to what my other approach is, where you're going to just have your own, you're going to have this thing in front of both Elasticsearch and the actual object store. I see another thing in the chat is information services. Okay. Yeah, it does. It has so an inverted index is what you use for text search and Elasticsearch, and so it is able to do text search. So that's why this approach was cool, but you can't query Elasticsearch directly from the browser, and so then you would also have some issues with that. Use 128 bits, so quite large, but if you use a smaller key size, yeah, I tried to outsource the whole key generation part, which I forgot to copy over into the search case. Fun. Move that over here. Come on. Okay. Say 200 megabytes per record, or is that less compared to? I actually didn't look into other databases. I now need to do that. I now need to look into the limits for PostgreSQL, because I would be fascinated if PostgreSQL also supports 200 whole megabytes per record. I would be shocked if that's like a normal thing for databases to be able to handle, because you usually the records are like, maybe 100 bytes or like a few hundred bytes. And then like you might have if you have secondary indexes, you wouldn't want to do a secondary index over one of those massive blob columns. Well, so I mean, there's like the blob data type, but it's still, when I think of the blob data type, I don't think of like, 100 megabytes of data popped in there. That's kind of crazy. Okay, let's try and look at an approach where we stick a thing out front. Sarov definitely had a great idea there of putting maybe PostgreSQL out front. Another idea I had was maybe using a message broker in front of both of them, or let's go ahead and do Sarov's approach first, though. Is we can go ahead and stretch this thing, and we can maybe go ahead and have our you know what, I'm just going to copy this thing. This thing is not playing well with me today. It keeps zooming in and out. There we go. So we have PostgreSQL. And I mean, we could have our object store to the side, and then a DB. Oh, okay. So we can still have our object store to the side, and then we have a DB trigger to Elasticsearch. Oops. grab this one over here. I'm just trying to avoid sticking it directly into the thing as much as possible. So you have that, and then this thing has a DB trigger, and we'll copy that into Elasticsearch. Like that. And then you can do, well, so you have your DB trigger, but you would also want to copy the stuff from here over to it. I mean, you could go ahead and stick it right into Postgres, but again, then you have your bandwidth your bandwidth issue over here. And so that's why I wanted it over on the S3 bucket. And then you're still going to have that full bandwidth issue of you're still somehow going to have to get the text all the way over into that, which was the thing that I was having issues with. But, you know, search service straight off of this. And then have on. So when you have a DB trigger, you could even have task runners listening to it, and that could be how you pull it off of this, is that you would throw in, here, I'll illustrate what I'm talking about, is that you can do, so this is just kind of like drafting the data flow, and then you have your DB trigger directly. I've definitely seen something done like this before, where you can have you have your Lambda triggers listening straight to a database. This is totally feasible in AWS, is that you have some custom task runner stuff over there. And then you can have this pull from S3. And then it writes it over into Elasticsearch. And then you'd have the bandwidth bound thing over here, but I think it's maybe more acceptable to have it within a data center, having that huge bandwidth constraint, rather than having it an externally exposed, like having that bandwidth bound thing like straight to a client, I think is a bigger issue, because then the bandwidth is over their dial-up connection. And when you have a connection within data center, it's going to be a faster connection. And so I don't think it's as crazy to have that bandwidth bound thing going on right here. Again, this is why I wanted to do this question live, instead of trying to make a 6-minute video and then potentially totally screwing this whole thing up by suggesting something crazy like this. That might be 100% wrong, but this was my thinking, is that you might be able to do that and then stick it into Elasticsearch. And then if you wanted to roll your own inverted index, that it would just look similar to this. So before I had read that Elasticsearch actually does support 200 megabytes per record, I was thinking that you would just replace this with your own home rolled setup of Redis or something that's manually mapping from each term over to a list of text blobs that has that term. So you have like Redis instead of Elasticsearch or something like that, where it's a home rolled inverted index instead. And then I haven't even attached the downloader piece yet, which would be didn't need that, right? Yeah, I don't think so. And then we need the text downloader, which has the downloader service. And we're going to stick that over here like this. Then we're going to move this a bit, and he's going to talk directly to the S3 bucket. They're going to get the mapping from Postgres. Sure, it could be either Postgres or Elasticsearch. So that's one idea. And And let's check the chat out for how controversial the stuff I'm doing is. PostgreSQL allows storage of large block. Wow, 4 GB on Postgres. Wow. Yeah, that is seriously high. Any idea about Redis? If Redis is good, we can replace Elasticsearch with. Well, so Redis doesn't have a inverted index to my knowledge. And then it's also not durable. So like if Redis would be nice for a cache. Redis would certainly be a nice cache. So if we're going to cache the S3 blobs somewhere, Redis is one option. Otherwise, a CDN. So caching the PostgreSQL stuff is also really great as a cache. That mapping from the key to the S3 location, Redis would be great for that. But I don't think there's an inverted index in that, so it wouldn't be great in that spot. Okay, so it's 1 or 2 GB for new Postgres. Old Postgres supports 1 or 2 GB. Still, that's a ton. That's a ton. I'm surprised it supports more than Elasticsearch of all things. I totally thought Elasticsearch was just an outlier, but apparently Postgres also supports massive blobs of data. That's crazy. Okay, did I go over all the approaches that I wanted yet? This is from my draft notes. I had the potentially bandwidth bound approach. Did that first. I did the invalid approach. I shared that with you guys already. And then we went through the thing that Saurav came up with, which is great. I actually kind of like this. Yeah, I think this is, I think I was going to do something with a message broker here instead of PostgreSQL. Yeah, I was going to try and use a message broker, but this wouldn't have a race condition. One of the other concerns I had was that, so you would create the record here, and then you would upload the data, and then you send the ACK, and then the ACK is the thing that the task runners and DB trigger picks up on, have it look for the specific event, which is the completed successful upload event. And so then it would know to go ahead and keep going. My concern was that you could possibly have the task runner try and make the inverted index prior to it being completely uploaded. And I think that could have been what could have happened if you used a message broker instead. So using Postgres instead solves that issue. And I think I like this a lot more than anything that I came up with. Hopefully that is appropriately what Saurav was thinking with what he had said. I hope I did that right. Feel free to correct me if I'm wrong. Yeah, I like that though. I hope to see some comments if I did something crazy here. Otherwise, you guys might see a 6-minute video walking through all this at some point. And again, I got all my end-to-end estimates somewhere. Where are they? Here they are. Yep. I already went over the latency estimates. I might actually have those in the video. I've never tried latency estimates before in any of these videos. So maybe we can get some comments telling me if I'm crazy or not. I think we've covered everything I wanted though. Thanks for watching, guys. I can't think of anything else I wanted to cover. So thanks for joining me. You guys have a wonderful weekend. See ya.